Welcome to this SciChem and BMS microscope course, Microscopes and Measuring. We're going to show you something about microscopes and measuring, as we said. First, we tell you something about the microscope principle. What do you do when you start measuring inside a microscope? We tell you something about the eyepiece, the graticule inside the eyepiece. We show you how to calibrate the microscope manually. And after that, we're going to show you how to use the digital camera and do the measuring also, but then by means of a software program. In this case, it's called BMS Pix3. For measuring, you need a unit, and the unit comes out of the International System of Units. Here you can see the 7 parts, that is the head parts of the unit of measurement. We're going to use distance measuring in meters, or better in micrometers. And here you can see where the micrometer is in line of big towards small to the right hand side. You see 10 to the power of -6 is it called, I think, in English. That's the one we're going to use. Shortly, it's micrometer. It's the Greek letter mu, that is referring it to this distance. What is it in general? What do we have to think about a micrometer? How big is that? What kind of dimension do I have to think of? Here's a few things to give you an idea. It's the smallest detail we can see through a light microscope. It's the width of a bit of a compact disc, a row of 5,000 atoms, or 100th of the thickness of a newspaper sheet. Well, you can see that is giving you an idea, but giving you an idea, that's not enough. We want to do a proper measurement, and if we make it a measurement with units, we of course have to calibrate the microscope. These are the 3 main items for doing a proper measurement: the microscope, the eyepiece with a graticule, and the graticule of course is a glass disc inside the eyepiece with a scale on it, but the scale doesn't have any unit. That exactly is what we're going to do. We're going to give that scale a unit, and we're going to do that by the use of a stage micrometer, an object micrometer you see here on the right hand side. And these give you the microscope with a calibrated eyepiece, and where you can make your measurements with. Not only here, but you can compare it, of course, with a microscope of your next door neighbor, but also of somebody on the other side of the world with his own microscope. The moment you start calibrating, then you can compare the measurement that you've made. In the following part, we're first going to show you how to manually calibrate the microscope, and after that we're going to do it by means of a digital camera. Measuring with the microscope. To do a proper measurement, you need a few items before you can start. Of course, you need the microscope. This one here is the BMS D3. It's a microscope with E-plan objectives, LED illumination, color illumination on the lighthouse. It's a trinocular. I put a camera on top. It's the main part of doing a measurement with a microscope, but for that you need 2 other items. You need a eyepiece with a built-in graticule. It's a kind of ruler, as you see on the screen here. This is the camera. This is the ruler inside the eyepiece. The eyepiece is in between the camera and the microscope. And here you see a scale starting from 0 up until 10. It's divided in 100 parts, so each part, each number is 10 parts, altogether it's 100 parts. It's parts, there's not a unit to it. To bring a proper unit to these scales, you need a stage micrometer. The stage micrometer is an object, a slide, with a small centered image, and inside that image there is a millimeter divided in 100 parts, and each part is 10 microns. Altogether 1 millimeter is 1000 micrometers. We go now to have a look at the eyepieces with the 10 times eyepiece with the graticule, together with the stage micrometer, and we have to calibrate each objective, because the moment that you start changing the objective, you change also the total magnification. Magnification of a microscope is made by the eyepieces in combination with the objectives. If you have a 4 times objective and a 10 times eyepiece, together you got a total magnification of 10 times 4 is 40 times. With the 10 times objective, 10 times eyepiece, you got 10 times 10, you got a total magnification of 100 times. With a 40 times objective and the 10 times eyepiece, of course, you get 400 times total magnification. First, we start with the smallest objective, the smallest magnification, which in this case is the 4 times. And if you look at the image, you can see already in the back, you can see the stage micrometer moving here, and in front you see the ruler, the graticule inside the eyepiece. It's very handy to have a microscope with a mechanical stage if you want to do measurements, because you want to have a precise movement of your slide, like I do here. Well, I've put the graticule inside the eyepiece on a horizontal level, which makes it easier now for me to line both rulers just like that. And you have to find the best overlapping moment. I can actually focus it a little bit. And if I have a quick look and I see the stripes of the stage micrometer, which is the bottom scales here, and align it together with the top ones, which is the eyepiece graticule, then I can see roughly that I have here a perfect match. If I start here and I go up to 2 in the eyepiece graticule, it equalizes exactly half of the stage micrometer. That means that there are 5 big stripes here, 1, 2, 3, 4, 5, which makes it 500 microns. Total was 1000 micrometers, I have to say. 500 micrometers equalizes 20 units of the eyepiece graticule. We can put that in a table to make sure that we have all the figures right. So we see there 4 times, the objective 4 times is on. Total magnification was 4 times 10, 40. Number of stripes in the eyepiece, which is 20. And the number of micrometers that we have measured in line with the 20 is 500 microns. Then we go to the 10 times eyepiece, 10 times objective. And you can see here already that stage micrometer all of a sudden is much bigger than it was with the 4 times objective, which is not surprising, of course. And again, you can find the focus of the stage micrometer like here. Let's line it up as good as possible with the eyepiece graticule. It's not too bad, I would say. A bit further. We can say that they match. So the 10 or the 100 stripes in the graticule equalizes the 1000 microns in the stage micrometer. So you got 100 times total magnification, you got the number of stripes is 100, and it equalizes 1000 micrometers. Now we go to the 40 times. I have to put up the light a little bit. The higher you go in magnification in microscopy, the more critical the light becomes. So higher magnification requires also a bit more illumination. Let's find here the stage micrometer. Here it is in focus. Make sure it is in line with the ruler in the eyepiece. Well, if I look at it, it's proper to go from 0 to 4 here, and it equalizes exactly one major part in the stage micrometer, which is 100 microns, equalizes 40 units in the graticule. So total magnification is 400, 4 times 10. That number of stripes in the eyepiece is 40. And the number of micrometers is 100. Now we can do the calibration of the calibration factor of the several objectives. Let's start with the 40 times, the 4 times objective, the 40 times total magnification. We have to do the factor is the S, which equalizes the 500 micrometers divided by 20. That's 25. Then on the 10 times eyepiece is 1000 divided by 100. It's 10. Then we got the 40 times, which is 100 divided by 4, equalizes 2.5. These 3 factors are our calculating factors. By rights, you can say, is it a can give a unit to it? By rights, yes, it's the micrometer, but on the other hand, it's the factor that you need to have your measurements done with the several objectives later on in a real slide. And we're going to do that right now. We're going to move the stage micrometer. You can lose it now. We can have a proper slide. I got here some prepared slides, and I take the slide where you can see a ficus. It's a leaf that has been cut, and now we can have a look at it, and we can do some measurements. It's just an example. You can, by rights, you can measure now any other slide because the factors are now known. But let's see if we can get a bit of a nice image. This is the 4 times objective I've got on right now. We're going to find, there it is. That's a nice image. You see, very colorful. It's a leaf cut in queer, and what you see now is that your stage is the slide, but you can still see the ruler in the eyepiece. The eyepiece is still, of course, in between the camera and the microscope. How can we do a proper measurement now? Because I want to, for instance, I want to have a measurement done roughly here where the part of the leaf is. I want to know what thickness has this leaf. So we have to measure it with the graticule. But how can we do this? Because if I move it now, I can move the slide, but I can't really make a proper measurement. What you can do, of course, is make sure that you move the eyepiece. It looks like I'm moving the slide, but that's not true. The slide is here, it's fixed. And what I'm doing right now, I'm moving the eyepiece in such a way that I can make a proper measurement. And you don't have to, of course, have to start all the time with 0, but the only thing is, if I start here now with 2, then that, of course, is my 0 point. By rights, you can start with 0 as well, right here. But normally, my focus is a bit better in the center of the image, rather than take it on the side, on the rim of the image. Well, let's put it as good as possible in line. And if I measure now from here, from 2 all the way up, it's about 6, isn't it? It's 6 little stripes. So 6 of those little stripes I can see right now in my eyepiece graticule. Let's make a note of that. At the 4 times, the calibration factor that we found in our calibration table was 25. The number of stripes in the eyepiece now is 6. And now, of course, each stripe equalizes the 25 micrometers. So 6 times 25 is altogether 150 micrometers. That's what we've just measured. If I go now to the next objective, the 10 times objective, we have to find the slide again. Let's make it more or less the same. I have to focus it a bit. That's it. Now I have to lower my ruler a little bit, because that was the more or less the same spot as I had on with measuring by the 4 times objective was on. So let us have a look what we have here. It's could be 6, 5, 6, 6. Number of stripes in the eyepieces, then of course 15. Let's put it on, make it 15 there. And the calibration factor that we found was 10. 10 times 15 equalizes 150. Let's go to the 40 times. More or less on the same height. And you can see there the red part that we already saw in the lower magnifications. We have to start. It's about 60 that we can count. It's from 3 up until 9, which is 6 major parts from the graticule. Each major part is 10, so 6 times 10 is 60 that we can measure there. Number of stripes, and the factor was 2.5. And 2.5, 60 equalizes 150. Was this to be expected? Because we make measurements at different magnifications. But of course, if you have done a proper calibration, it shouldn't differ. You measure more or less the same place in the slide. So with different magnifications, you should get the same results. And that's exactly what we see here. Must be honest though, that this is what I've just seen is spot on. Normally you can have some difference. You can see as well, if I find 150 microns or 140 or 160 microns, what is 10 microns on magnification from 4 to 10 to 40. You have to be reasonable there. And we spoke already about measurement failures, about reading errors, etc., etc. You can see here reading error. If I look at the tree here, I start here, but you can see there's a bit of information still on the left-hand side. Does that belong to the slide, to the actual distance that I want to measure? That, of course, you have to allow yourself some space there. But nevertheless, yes, it was expected that all these figures should be more or less into the same range, and that is what we've seen here. Right, we see now how to manually calibrate the microscope. And of course, we would like to do some recordings also, and we have cameras for that. And fortunately, the camera software also has measuring programs. And I'm going to show you now how to calibrate that measuring program, BMS Pix3. That's the software that accompanies our cameras. I'm going to show you now how to calibrate this specific software. Of course, we have to do this again per objective. As I stated earlier, each objective has its own magnification, of course, and for each magnification you need a calibration. Very easy with the program is that you can store what you have calibrated. So once you've calibrated the microscope, the objectives, together with the camera, you can use it in numbers of sequences following after you've first calibrated it. Let's have a look at BMS Pix. Here you see the program opening. On the left you see no device. It's searching now for the camera that's connected to the computer, and now you see the name of the camera popping up, which is this camera. We're going to open the camera, and here is the live image. As you may recognize, that's where we left it when we did the manual calibration. It's at the 40 times. But as I said before, we need to start to calibrate again. So we use the slide here. Take the slide with the millimeter on it. Let's find this wonderful millimeter divided into 100 parts, and each part has 10 micrometers in it. Here it is. Well, to make it all a bit more visual, we're going to put it in a horizontal way also. It's a 4 times objective. The camera is now connected by means of a wide field 10 eyepiece, more or less. It's screwed into the C-mount winding of the camera. The connection is made directly to the trinocular in this case. And what we do now, as you can see, we have focused now the millimeter, which is divided in 100 parts. Each part is 10 micrometers. As you can see, we see the micrometer here in focus. Is it really? Yeah, that's better. That's better. And now what we can do is start the calibration. We open the calibration program inside Pix3, and it's asking now to adapt the zoom level, which I'm not going to do it. We can still continue as it is. And what you can see now is the red line. This is the calibration line. I can move the red line any position. I can make it a bit shorter also. And what we're going to do is we're going to put it just like we did with the manual calibration. We put that calibration line on top of the micrometer. Make it as smooth and straight as possible. There we go. Now we see that we have the actual length, magnification first. We fill in there. That's the 4 times. The actual length is 1000 micrometers. We fill it in there. We give it an OK. And now the 4 times, you can see it here in this pop-up menu, the 4 times is calibrated. Let's have a quick look to see if we make a line measurement. We can here choose line measurement. We take the line, we go to measure, you see the little cross there, from here to, let's say, here. Let's have a look. It's 1, 2, 3, 4 big units, which is 400 microns. And what does it say here? 401.1 microns is measuring. So I think we done a proper calibration here for the 4 times. We're going to move it now to the next, where is my, here it is, to the next, I'm going to lose this figure, going to go to the next objective, which is the 10 times. Okay, this is the 10 times, so total magnification 100 times. We're going to do the calibration again. It's asking again about the zoom level. I'm fine with that. And we can see here again the red line, that is the calibration line. We're going to make it a little bit smaller. Position it again, starting on the right hand side. There's a little square there that I can actually fit around that last bar. And now I'm going to enlarge the red line again till the beginning. Are we there? It can go a bit slow. Is it better this way? This is the best, I would say. From there on, wait, we moved it in the wrong way. Let's start again. Make sure that we are, yeah, that stays on the back now. I was moving the complete line and it should only extend the length a bit. What you can see now, it starts at 0, ends at the last bit of that micrometer. Again, we put in the magnification here 10 times. It's 1000 micrometers again. There it is. Give it an OK. It's calibrated now for the 10 times. Just let's have a quick look to see if we're right here. If I start from here, go all the way up to here, and lose it. It's 1, 2, 3, 4 big units, which is approximately 400 microns. We know that micrometers, we know that already. And if we look at the measuring sheet, it gives us 401.38. Not too bad, is it? We lose this one again to go to the last magnification. It's the 40 times objective. Here it is. Let's find the. And magnification is now in such a position, that such a strength that I can't see the complete millimeter in one view. So I have to do it with a part of it. Nevertheless, we can do a measurement, we can do calibration anyway. So again, we go to the calibration. We find the line again, we've got it here. There it is on one part, on one big bar there. You can take any bar you want, of course. So normally I take it as long as possible, because the longer you take the measurement, the better it is for minimizing your reading errors and your reading mistakes. Now making the line a tad larger again, so that it is going to fit straight on the bar here. From here to here, it's altogether 200 microns here, 100 micrometers. 100 is 1 bit. This is 200 micrometers. We say the magnification, we give it the 40 times. It's 200 micrometers. We say okay. Let's do a quick test. Let's measure from here to here. Well, let's make it a half, why not? And it says 101.35, which is, in my opinion, close enough. We're going to lose this micrometer now, and we're going to put on the slide with the figures again, like we used when we were calibrating manually. Here's the figures. It's at the 4 times magnification, and you can see here the spot where we did approximately the measurements in the first calibration session. To calibrate, of course, is not necessary anymore because we have that done. I've done that already. What you have to do though is make sure that you choose the right calibration, the right objective. The 4 times, it's the 4 times objective. Put in the 4 times here. And if I start doing a line measurement, for instance, I can go from here to here. But you see there is this little cross, and it has a nice horizontal bar and a vertical bar. And to make the measurement as good as possible, I prefer, but that's my own preference, to have it as good as possible leveled on a horizontal level. Here was approximately the line that we used to measure. Let's do it again. I start here, go all the way up. Wait, I have to do this again. I lost it here. I just delete this measurement and do it again. Start from approximately here up to, that's it. What have we measured there? Let me have a look at the measurement sheet. It says 147.88. Well, we know from the first measurement that we did, that was 150 micrometers. We're getting here 147.88, which is not too bad. That's almost the same, isn't it? Let's see what happens if we go to the next objective. We lose this value here, turn it to a 10 times. Almost back into focus again. This was more or less the area where we were measuring in. We have to choose the 10 times. Let me show you what happens after we've done this with the 10 times. We measure with the 4 times. If you make a judgment mistake and you forget to change the objective. We do a line measurement again. About somewhere around here. All the way up to here. What does the measurement sheet give me here? 149.89, which is 150 micrometers. If I change now, for instance, my objective here, let's go to the 4 times, it gives me a different value. You can see all of a sudden it's 374.89, let's say 375 micrometers. It's not the right measurement done there because I have the wrong objective. The objective was a 10 times. We can correct ourselves straight away, and it now goes back again to the 150 micrometers that we were supposed to measure. We lose this value again also, and we go now to the 40 times. This. Are we in the? Well, you can see that I got very little space on the top and on the bottom, and I don't want to do 2 measurements. Like for instance, I do 1 measurement here halfway, then I move my slide and do the second half, which gives me, of course, more reason to make mistakes. What we can do now is, for instance, completely rotate the image. You have to know for sure where we are. We can center this one. We have to go up a bit. And now we can see the place where we used to measure. That was around this area here. Let's put it first a bit better in focus. Around this area here. We go to the 40 times objective, choose it here. It's now calibrated for 40 times. We do a measurement. Let's go from, let's say, from here all the way to up there. Let's see what the results are. 150.62. I would say we're pretty close there in the same area, because you can see now as well, again, what is part of the real slide or of the real cells, or what is a bit of cutting damage as you have when you cut, of course, through tissue. I show you another thing also that can be done with this program. We can, for instance, do a measurement, a rectangle measurement. Like if a cell is more or less rectangle, you can of course say, oh, let's see what this size is more or less. And now you can see a value here, and on the measurement sheet it says R1, that's the area that we've measured. It gives you the length, and it gives you the width, and it gives you the area measurement, 190 square micrometers. I can do a circle measurement also if I want. After like I've done, where is it? Here is the circle measurement of 2 points. If you have, for instance, a core of a cell, you can measure that. That's, for instance, we want to have this shape here. In circles, you can see here, when you see the measurement C1, it gives you the diameter, it gives you the area, and that is of course interesting to see also. If we do another length measurement, for instance, oh, wait, this is another circle, and I can lose this one. Yep, there it is, it's gone. If I do another length measurement, for instance, second length, I want to measure just something from this point to up to here. It's now called L2. L1 measurement was the first one we did, the 150 micrometers. The L2 in sequence, it's the second length measurement. It's doing the same with the circle ones or with the rectangular ones. It gives it number in sequence, following each other, of course. Another measurement we can do is the polygon one on several points in an area. And of course, if it's not really rectangular, then this will give you another value, a more accurate value. Again, it gives you the area also, so that means that you can still do the area measurement, but with several points of measurements. This can all be stored, of course, because it's a computer program, it's connected to the PC. If I switch it off and I restart it again, it's already calibrated. You don't have to do the calibration again. Once you've calibrated, you put it into the system, it stays there.